Hello everyone, good morning, good afternoon, good evening. Thanks for joining my channel Cloud and Coffee with Update. In this video we are going to learn about building the transactional data lake on AWS using Apache Iceberg. So even before we go and learn about how you can able to build this transactional data lake using Apache Iceberg, let's understand how we reached to this state. So let's understand around the brief history of reaching to Apache Iceberg and how we have evolved. So initially we had this databases, right? We all know these databases are, we call it OLTP, online transactional processing databases. Those are primarily Oracle, MySQL, MS SQL, PG SQL, etc., right? Those were are meant for primarily for building those transactional kind of an application, and you're able to run a report, but those are not very performant in nature, or you cannot able to have a report which has been going and scanning a lot of data, and you're not able to do a lot of data aggregation. And thereafter we have something called EDW, Enterprise Data Warehouse or Data Warehouse. So those are the OLAP kind of OLAP online analytics processing engine, right? So we had this OLAP, and in OLAP we had something called let me put this here. We had this Oracle, DB2, Teradata, data, etc. So these are primarily meant for us you to perform those BI reporting, right? So you will be looking to do all kind of BI reporting here on this databases, and those were good for you to perform. Those are really good for you to perform your reporting. So these are very good for you to do the data aggregations, right? So you're looking to perform a lot of data aggregations. It allow you to do the data aggregations, right? So you can able to generate your reports. Those were really nice. These were working fine. The only drawback this one is first, like a couple of drawbacks which we can think of. One is definitely it's an expensive. So as data grows, right, keeping and maintaining those were very expensive. So other very big challenge was this were having tightly coupled storage and compute, right? So storage and compute were really tightly coupled, I can say. What does it mean, like when we say storage and compute is tightly coupled? It means if you are looking to add more data, you have to increase your compute power, or if you're looking to increase your processing power, you have to add additional storage, right? There is no way you can independently scale your storage, and there's independently scale your compute, right? So you can't be able to scale your storage and compute independently, so which eventually also kind of add up into cost. Other drawback was, or con I can say, with this approach was schema on write. So it means you have to define schema upfront, and so CHEMA. So you have to define the schema upfront. So if you have an applications where you do not, or if your application is constantly changing, it will be super difficult for you to maintain it. That you have to keep kind of updating your schema. So if you're updating your schema, you have to maintain all the works. And again, right, even Redshift and Snowflake and all those databases also had a similar problem initially, But Redshift and Snowflake, I will be talking there later, means how that evolve. So this is before 2025. So all these things which I'm talking about 2025, let me not 2020, sorry, not 2025, it's 2015. So before 2015, I don't think even Snowflake was there. So anyways, hopefully you got the sense here. So we had this changes in it. In order for us to have this changes or this drawbacks which we have from the data warehouse, that is an expensive in nature. You can't able to tightly couple storage and compute and schema on a read. We went to something called data lake, right? So we went to the data lake architecture. So this is your Amazon S3. Those are an object store. Let me Amazon S3. These are object store, so you can able to store any objects, right? Here. So we had this advantage of this one here. So advantage of a data lake or Amazon S3 data lake, let me call it data lake, right? So advantage of this one here is, first of all, like you can able to these are little inexpensive, if I have to say, right? And you can able to store as much as data. You will allow you to store huge amount of data. It allow you in a fraction of cost what we used to do in a data warehouse. And then you will be decoupling of storage and compute. So compute, what does it mean? It means you can have as much as data being stored into your data warehouse, sorry, in your data lake, and then you can use the compute engine of your choice. One perfect example is you will be having data stored into into data lake, and then you will be using Amazon Athena to query the data, right? So this architecture is let me showcase. So you will be having this data lake, and then you are choosing Amazon Athena to query the data. So this way you can use only using the power, only using right, how much data you're looking to query. You can only able to pay for that, or you can able to use processing engine like AWS Glue to process the data, right? So you can able to use Glue to process the data. So you will be like, hey, this is for Athena, this is your query engine, this is your AWS Glue, which allow you to perform the ETL. The whole concept is you will be decoupling that storage and compute, and so you can able to have as much as data being stored. And if you're looking to just process, let's say you have stored terabyte of data and only looking to process that couple GB of data, you can able to do that using ETL, right? And only if you're looking to query few GB of data, you can able to query using the Athena. So this is like, this is perfect. And okay, this is a schema on a read. So that is more like a schema on a read. When we say it is when we say, like, it used to support schema on a read. So you have not to define no upfront schema, right? So you don't need to define your schema upfront. You don't need to know upfront schema definition needed. What does it mean? It means you're moving from extract, transform, load to extract, load, and then transform, because you will be not defining your schema upfront. Only once you brought your data in, and once you're looking to query the data, at the time you need to define the schema. Before that, you can have this data being stored into your data lake. These are right? So these are all the advantages we have within the data lake. But one thing which is being offered by data warehouse, that is if I say if I have, there's one biggest advantage apart from like it allow you to perform the data aggregations at the scale. Other advantage it's being offered by is ACID in nature. What does it mean? It means you're able to perform any ACID transactions, such as you're able to perform insert, update, delete, right? All those operations you're able to perform against your data. You're able to go and update the columns, column name, etc. Those can be easily done against the data warehouse, and that is the biggest drawback which we have with a data lake, right? So in a data lake, you can't able to perform. So no ACID transactions were allowed. So if I have to go and write here, so these are the advantages. If I have to go and write the disadvantage, no ACID transactions, right? So okay, now in order for us to have those ACID transactions and no ACID transactions, what usually people used to do is they used to have something called this lakehouse architecture, right? So, or you can say, yeah, so they move from the data lake to lakehouse architecture, data lake. So how, even before that, like how you people used to solve this one? So they used to have two different approaches. So they used to have a data warehouse and let's say Redshift. So they used to have this Redshift, let's say data warehouse. Okay, so how they used to solve this problem? So they used to have all this historical data in data lake, right? And then more like current data in a data lake, data warehouse. Data warehouse. And they used to have some ETL tool to move the data between data warehouse and a data lake. So it should be, I think, it will be the both. This arrow will be both because they will be moving. They are moving this from both the directions. So right. So here we are having this ETL process which allow them to move the data between data warehouse and data lake. Okay, where, yeah, should be, sorry, my bad. Okay, anyway, so do you got the idea? So here you're able to have a ETL process which allow you to move the data between the data warehouse and then between the data lake and data warehouse, right? So, but the drawback, so here is the challenge with this one. So you will be looking to you should be having to have some kind of an ETL process in between, which have an added cost. Also, the data is not like it's not in a real time, because again you have to have a ETL process in place. And when you start having and start working with streaming data sources, then it get really difficult, right? So that's where we are having now, we have moved from something called lakehouse architecture. So how we able to achieve what we have within the data warehouse, that is your ACID transactions allow you to do the data aggregations, etc. And what the pros which is being offered by your data lake, that is decoupling of storage and compute, schema on read, right? All those nice things. So that's where industry went from data lake to lakehouse architecture. So okay, so here in the data lake to lakehouse architecture, we had so we had this data warehouse. We move from data warehouse to data lake, and then from data lake to lakehouse architecture. So one more thing which you need to understand when we talk about all these things, or maybe other things which can be helpful for you to have a better understanding to around this architecture, is if we talk in a broader term. So here we had I'm talking about a data warehouse, and then I will talk to you the data warehouse, and then I will go and talk. No, I will talking about others as well. So let's say in a data warehouse we had something called storage layer, right? We all know. So this is the storage layer, and the storage layer we had this proprietary file format. Every data warehouse has its own file format, right? Example, Redshift has its Redshift storage managed storage file format, and thereafter we are having this table. So it will you able to kind of able to see able to query the data. So that's how the table format look like. And thereafter you're going to have a compute engine, and then you're going to have a storage engine. So let's say you are having this storage engine, you are having this compute engine, and you're going to have means you will be in the modern data warehouses like Snowflake and a Redshift, etc. It has something called catalog as well, like, right? So it will be maintaining the catalog of your database and etc. So and there are oh my god, so let me fix working with drive sometimes is challenging. catalog, catalog. We're going to have this catalog, and the catalog on the top of it we are going to have all kind of a data consumption tool. So we will be having all kind of SQL tool, BI tool, etc. So this will be data consumption tool, tools, engine, whatever you're gonna call it. Okay, so this is the architecture of a data warehouse. So this is your data warehouse. Now how we move from data warehouse to data lake. So in a data warehouse, so if I have to copy this entire thing, hopefully it's not letting me here. Anyways, I will be using same one. So we had this storage layer. This storage layer is your S3. I'm just giving an example. S3, it can be an Azure storage as well as GCP cloud storage as well. Thereafter we had this once we had the storage engine, we had this file format, right? So you can have any file format such as Parquet. And again, this is the other advantage. You can have an open source file format, whereas here you have to have proprietary file format. Here all these are open source file format. I'm just giving an example here. Parquet is just one example. And thereafter you're going to have a table format, right? So let's say we have the table format. Here we are talking about table format is your Hive. Hive was one of those first table format. Okay, and that you can have your thereafter you need to have a compute engine, right? And then you can have your data catalog. So you will be creating this data catalog. You have this compute engine, and this is thereafter you will be having data catalog, and thereafter you will be having any kind of a consumption engine, how we are having here, right? You can have any consumption engine. You can able to have this one here. So this is how your data lake look like. Okay, now how the lakehouse architecture look like. So similar what we're having here. So we're going to have storage engine, we're going to have a file format, and thereafter we're going to have a table format. Here in this table format, we're going to have a new kind of a table format, not Hive, like the new kind of table format, which is Apache Iceberg, Hoodie, Delta, right? So these are the table format which we are having here. On top of it, we're going to have your compute engine, right? What all kind of compute you're looking to use. Sorry, compute engine, and then you're going to have a catalog, right? And thereafter you're going to have your data consumption engine. One thing which is here is you don't need in this data lake, you don't need to have a file format. You can directly able to work with the file itself. You don't need a table format. Like for instance, if you're looking to use tool like a Spark, you can directly point that Spark to the S3. You don't need a any kind of a file format in between. Similarly, you don't need a data catalog if you do not want to have the data catalog in very first place itself. You can choose compute engine of your choice, etc. So those are some of those things. Here, what we're talking about, okay, you will be pointing to the table format and performing all the operations. Now let's understand what this table format is. Hopefully you got the sense. So when we say about when we talk about data lake, right? So even before the data lake, you must have heard something called SDFS, right? Hadoop distributed file system. The whole concept about it, how you can able to have the distributed file system which allow you to perform data processing across the distributed infrastructure. So the one thing which is like when you're working on an abstract layer, such as like, hey, if I'm looking to work as a data engineer or data BI developer, I need some kind of a table format, right? So this way I can easily able to understand what how my data is being stored within this file system. For that, I need something called this table format. So table format is nothing but it provide you. So if I have to draw again a diagram, so let's say I'm having this bunch of file, Amazon S3 files. Let's say having the files here, and then bucket A, bucket oh my god, bucket, yeah, this is let me call it bucket A, and then this will be your bucket B, and then bucket A stored all kind of file, bucket B store all kind of file. I need to know what all data is there in bucket A, bucket B, in more like a table and or table structure. I should be using I should be using let's say this is bucket A. That's what the Hive table style will be useful. Okay, so this is table Hive style, which is being pointing to let's say if it is pointing to bucket A, then we are having the same table which will be pointing to bucket B. So I can easily able to go and see how the data is being stored, right? So I don't need to worry about if I'm having this bunch of a Parquet file sitting in this one and that is being partitioned, etc. I don't need to worry about how that is being structured. I can easily able to see using this one what all columns are there, etc. right? Or it's become very tedious. So hopefully you got a sense now how this has been. Now the one drawback or the cons I have to say between now, hey, we already have this Hive style. The other thing which is being not offered by Hive is the ACID transactions, right? It allows you to perform the read and everything as such, but if you have to go and modify the data, it's still a tedious job. And that's where we are having the evolution of Iceberg, Hoodie, Delta, etc., which allow you to perform all kind of ACID transactions. Apart from the ACID transactions, it also offer you something called if I have to go and okay, if I have to go and okay, so apart from ACID transactions, it also offers you something called, first of all, this ACID. It's allow you to perform all the ACID transactions. Other, it will be offer you the time travel. Travel capability. Third one, it will be offer you the schema evaluation. The fourth one it offers you is schema evaluation. The fourth one it is offers you is what else? Time travel, schema evaluation, and the fourth important is data compaction. So let's understand one by one all of this. So ACID, I think we all know what ACID is. Allow you to perform all kind of update, insert, update, delete, alter, add, drop. So that will come. So anyways, so this is like, you know, you're all able to perform against the ACID transactions, right? So this is there. Other is you having the time travel. Time travel is that I will be explaining later when I will be talking about this feature, but just for time being, just understand. I will be explaining under like how it's able to help you with the time travel, right? What goes behind the timetable, the inner working of time travel. But for now, just understand what the time travel is. It will let you go back in a time and see how your data is being like how data has evolved over the period of time. So this is there, right? And the third one is schema evaluation. So if schema evaluations, think of, right, hey, if I have to make a changes in a schema, right? So let's say in the data warehouse, if I have to go and update the schema, or if I have to add a new schema, that's a very tedious job, because you have to have a new data being added for your newly added schema. You can't just able to go and update the table definition. You can't right? You have to create a new table. You have to kind of copy those data to the new table. And when you will be copying the data, you will be putting those data into the new table, right? And then again, you don't know how the previous what's the previous column look like, what's the new column look like, etc. So it is a tedious job. Like, you have to have some kind of ETL in order to perform the schema. The fourth one is when you're having, and the biggest drawback with the data warehouse in data lakes is the data compaction issue, right? So if you have a lot of small files, especially if you're working with the streaming a use case. So streaming use case usually generate very small files, and when you work with the data lakes, working with this streaming, like, you know, it generate a lot of small files, and you have to scan, if you're performing any query, it has to go and scan all those files, and which eventually have a, you know, hamper your performance. So it's recommended to, when you work with the data warehouse, when you work with the data lakes, you have to have a file size in MB. But if you have a file size in a KB, that become very problematic, because now the engine like Trino, engine like Spark, they have to go and perform a lot of data scanning even before they able to provide you result, right? So that is kind of a very resource extensive intensive process. So hopefully you got a sense how we have evolved, how this is being brought together. We will be going in now in the next video. I will be going and talking about Apache Iceberg architecture, and then we will be going and learning about how you can able to build your transactional data lake. Hopefully this video is helpful. If you like it, please do like and subscribe, and like, subscribe and share my channel. Thank you very much.